We'll be doing 2008-2009 semester 2 question 16. Part A. State the Arrhenius law and explain the significance of activation energy and the frequency factor. The activation energy and frequency factor is independent of temperature. Activation energy can increase or decrease with increasing temperature. Frequency factor will increase with increasing temperature. Part B. State the assumption of Arrhenius equation and state its validity. In the Arrhenius equation, the assumption is that K0 and activation energy remains constant. This is, however, not practical because in a reaction, the reactants decrease in time. Ko, which is the frequency factor, will decrease and less reactant would result in less energy to overcome the activation energy. In part C, we'll be plotting the graph. We are given the K, which is the rate constant, and temperature. So we need to get ln K and 1 over temperature in Kelvin. So when we plot the graph, this is what we got. From the graph, we can see the equation that y equals to negative 14666x plus 39.083. So from the equation, we can use it to find our activation energy and our K0 based on the equation above. We know that 1 over T is our x-axis, and we know that negative EA over R is our gradient. So our gradient, which is negative 14666, we can find our EA using that equation. Whereas from our ln K, we know that it's the y-intercept, so we can just find K0 by just using the exponential rule. Lastly, part D. Predict the rate constant at 130 degrees Celsius. So firstly, we convert the temperature to Kelvin, and from the graph, we get the equation. First, we need to find ln K, which is 2.69094, and then we just bring over the ln, and what we got is 14.7455 over seconds. It's actually not valid as the increase in rate constant is too high over a small temperature change. If we were to look at the previous result, we can see that the K is actually very small compared to the result here. At 130 degree, the K is actually 14. So that's why we find that it's not valid. Thank you for your kind attention. We have come to the end.